distance between 2 points in the three-dimensional space. So consider the three-dimensional space with the three mutually perpendicular axes, x-axis, y-axis and z-axis. And also consider 2 points P and Q with the coordinates x1, y1, z1 and x2, y2, z2 in the space. So the coordinate space with the three axes, x-axis OX, y-axis OY, z-axis OZ, or the three positive directions of the axis. And suppose P and Q, any 2 points in this space. P with the coordinates x1, y1, z1, Q with the coordinates x2, y2, z2. So we can find the distance between these 2 points, the distance PQ, in terms of the values of the coordinates. Now, for this, what we do is construct a rectangular box with the sides parallel to the coordinate planes, and PQ is one diagonal of the box. A rectangular box whose sides are parallel to the coordinate planes. What are the coordinate planes? X O Y plane, this plane. Y O Z plane, this plane. Z O X plane, this plane. The sides of the box are parallel to these three planes, and this PQ is one diagonal of the box. So let us construct that box first. So draw the edges. So the edges are drawn. P is this point whose coordinates x1, y1, z1. Q is this point with x2, y2, z2 as coordinates. Now let us name certain other points also which are important. So let this point be A, this point be this Q, and C, A, B, C, and this point D. And now join this QC. Join this QC. And now consider this angle. Angle PCQ. Angle PCQ, which is clearly 90 degrees, because this PC is an edge and this QC is on this side of the box. This side of the box. So this side and this edge are perpendicular, and therefore this is perpendicular. And now this QP is Q. PQ is the diagonal of the box, and also this is a right angle triangle. PCQ is a right angle triangle. And therefore from that right angle triangle, using Pythagoras theorem, PQ squared is equal to PC squared plus CQ squared equation 1. This PQ squared is equal to PC squared plus CQ squared. And again, consider this angle. Angle QBC. This angle is also 90 degrees, because this is an edge, this is another edge of this side, and these two adjacent edges are perpendicular, and therefore this angle is 90 degrees. And hence triangle QBC is a right angle triangle. this QC being the hypotenuse opposite to this 90 degrees. So QC is 90 degrees. QC is hypotenuse of the triangle. And hence, again using Pythagoras theorem, QC squared is equal to QB squared plus BC squared, equation 2. Now using equations 1 and 2, we see that PQ squared is equal to PC squared plus QC squared is this, which is QB squared plus BC squared, which is again equal to. And now consider this PC. This PC is parallel and equal to this AB, which is again parallel to this y-axis. And therefore, this distance AB is the y-coordinates of, the difference of the y-coordinates of this A and B. Y-coordinate of A is same as y-coordinate of this point B, which is y1. Y-coordinate of B is same as the y-coordinate of this Q, which is y2. And therefore, this PC equal to y2 minus y1, PC squared equal to y2 minus y1 whole square. And QB. So, QB is this. This QB is parallel to this DA, which is parallel to this z-axis. And therefore, the distance DA is, as in the previous case, the difference between the z-coordinates of this D and A. Z-coordinate of D is clearly Z2. Z-coordinate of this A is equal to Z1, which is equal to this QB is Z2 minus Z1, and hence QB squared equal to Z2 minus Z1 whole square. Finally, consider this BC. BC is parallel to this PA. And this PA parallel to this x-axis. Similarly as above, this distance PA is the difference between the x-coordinates of the points of this A and B. X-coordinate of this point P is x1. X-coordinate of this A is same as that of x-coordinate of this Q, which is x2, and therefore BC is x2 minus x1. So BC squared equal to x2 minus x1 whole square. That is PQ squared is equal to this y2 minus y1 whole square plus z2 minus z1 whole square plus x2 minus x1 whole square, or this PQ is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this is the distance between the 2 points Px1, y1, z1 and Qx2, y2, z2 in the three-dimensional space. Okay.